students, welcome back. Now coming to the next topic, that is the code optimization techniques. So in the previous video I explained what is the main principal source of code optimization, that is a machine dependent, and the different categories are there, machine dependent and machine independent. Now let's see the different techniques that are used in code optimization. So the code optimization is done in the different ways. So what are the different ways that it can be done? It can be done, the code optimization means you are going to reduce the code and you are making it as a more efficient target code. Okay, improve target code. The first technique is compile time evaluation. Compile time evaluation. And the next is variable propagation. Variable propagation. And the next one is dead code elimination. Dead code elimination. And still the code motion. The code motion. And the next technique is induction variable and strength reduction. Induction variable and strength reduction. Induction variable and strength reduction. So these are the different the 5 techniques of the code optimizing. If you want to optimize the code by taking the front end with the help of the intermediate code, whatever you are taking the source code, that intermediate code is converted into the code generation. You have to transform to the code generation. The code optimization can follow the compile time evaluation, variable propagation, dead code elimination, code motion, induction variable and strength reduction. Okay, so now let's see one by one. So what is this compile time evaluation first? Let's take each technique one by one. The first technique is compile time evaluation. So by seeing this word, what do you understand? What is this compile time evaluation? So let me take an example to explain this compile time evaluation. Let's take one equation. Z is equal to 5 into 45.0 by 5.0 into, let's take R. Okay, so it is going to perform 5 into 45.0 by 5.0 into R at compile time. So this equation is going to be executed at compile time. So it doesn't bother about what is the Z here. It's just going to execute whatever this evaluation is there. Okay. So let's take another expression. Suppose x is equal to 5.7 and y is equal to x by 3.6. So now the compile time, what it is going to be evaluated? It directly evaluates, the compile time evaluates 5.7 by 3.6 directly. Okay, it's directly substitute the value here and evaluate this expression at compile time. So this is a compile time evaluation. So whatever that we want to be executed, that will be executed. If any variables, if you want to insert any values for that variable, it insert and execute. Okay. So this is a compile time evaluation. Directly it is evaluating. So next is the variable propagation. So what do you mean by variable propagation? The second one is variable propagation. So let me take an example to explain about this variable propagation. So before optimization, let's take the code. Before optimization, let me take a code. C is equal to A into B and X is equal to A, and you have to tell D is equal to X into B plus 4. So this is before optimization. Let's see the code after optimization. So by seeing this, you can understand what is a variable propagation is after optimization. Means what's the main use of optimizing here? Optimizing the code. C into AB x is equal to a till d is equal to a into b plus 4. Okay. So here the variable is going to be propagate. Instead of writing x into b plus 4, we have directly written a into b plus 4. Okay. So actually you can eliminate this at the if you are doing the code elimination, but here the variable propagation is, instead of writing the variable x here, you directly write a into b plus 4. Okay, because the compiler directly takes this in equation rather than this. So if we take like this, it is going to substitute the a value and it gives the equation like this. So this is a variable propagation. So here after variable propagation, the a into b, okay, the a into b and x into b identified as a common sub expression. So these are identified as a common sub expressions. Now coming to the third one. So what is the third technique of code optimization? Dead code elimination. Dead code elimination. So the code that you are not using, you can eliminate that code in the program. So that is a dead code elimination. Let's see this. Take an example for this also. Before elimination, what is the code, and after elimination, what is the code? Let's see. I'm taking before elimination. Take the same example. C is equal to a into b. X is equal to, I'm taking b, and till d is equal to a into b plus 4. Okay. So this is before elimination. Now let's see the after elimination. After elimination, you are going to eliminate the code. C is equal to a into b till d is equal to a into b plus 4. So did you eliminate this? Because here we are not using this x is equal to b. So here we are directly written this a into b plus 4. Then what is the use of this x is equal to b? Okay. So this you call it as a dead state. This is a dead state. So after elimination, we remove the dead state, that is x is equal to b, because whenever used we are never used in the program. In the program we are not using x is equal to b. So better it's remove that state. That is a dead state elimination, dead code elimination. Now coming to the next technique, the fourth technique is a code motion. Code motion. So what do you mean by this technique? So what's the use of using this technique? It reduces the evaluation frequency of expression. It reduces the evaluation frequency of expression. Okay. And it brings loop invariant statements out of the loops. And it brings loop invariance statement out of the loop. Out of the loop. Okay. So let's see the example. What is this? I'm saying it is reduce the evaluation frequency of expression, and also it brings loop invariant statement out of the loop. Let's take an example for this. So here I'm just taking a is equal to 200, and while a greater than 0, b is equal to x plus y, and if a modulo b is equal to 0, suppose if the mod ab is 0, then I need to printf %d a. Okay. So this is a code I have written. So now I want to reduce evaluation frequency of expression, and it brings loop invariant statement out of the loop. So wherever the loop invariant statement is present inside the loop, you have to bring it out outside. Okay. So brings loop invariant statement out of the loop. If any statement that is loop invariant, okay, it is not used in the loop, there is no need to use in the loop, then bring that statements out of the loop. That is a code motion. So by using this technique, it reduces the evaluation frequency of expression, because the while loop has to be executed until the equation is success. Okay. until the equation is exit, it is going to be rotate. So every time the statements which are invariant statement, that has to be read every time. So to reduce that evaluation frequency of expression, we are bringing the loop invariant statements out of the loop. So how it is possible? Let's see the statement. So I am writing here a is equal to 200, and this is the invariant statement because there is no need of using this statement inside the loop. So better bring the statement outside the loop. B is equal to x plus y while a greater than 0. If a modulo b is equal to 0, then printf %d comma a. Okay, I hope you understand what is a code motion technique. So by using this code motion technique, the code is going to be optimized because the evaluation frequencies, we are reducing the evaluation frequency. Now coming to the last technique in the code optimization, that is the induction variable and strength reduction. Induction variable and strength reduction. So what do you mean by this induction variables and the strength reduction? So previously you had seen that what is the second technique, that is a variable propagation, and this is about the induction variable and the strength reduction. The strength reduction is used to replace the high strength operator by the low strength operator. You know, reduction is reducing. How you are going to reduce the strength of the equation? The strength reduction is used to replace the high strength. Just replace high strength operator. High strength operator by low strength operator. By low strength operator. Then you can reduce the strength of the equation. So the strength reduction means reducing the strength. How you are going to reduce the strength? By replacing the high strength operator by low strength operator, you can reduce the strength. That is a strength reduction. So an induction variable is used, whereas the induction variable is used in the loop for the following kind of the assignment, like suppose I is equal to I plus constant. So let's show you the example for this induction variable. Before reduction, the code, let me write. Before reduction, the code is, let's take I is equal to 1 while I less than 10. Enter into the loop. Y is equal to I into 4. Okay, so let's take this is an equation. Now let's see after reduction what will be the code. After reduction, I is equal to 1 and I have taken t is equal to 4. Okay, so inside that while t less than 10 and y is equal to t is equal to t plus 4. So here taking, if suppose the 4 is less than 10, I have to take y is equal to t and t is equal to t plus 4. So this is the use of the induction variables, and here we are reducing the strength. How we are reducing the strength? Instead of using the into operator, I had used the plus operator. Okay, the into is greater than the plus. The strength of the multiplication is more than the addition. I want to replace the high strength operator by low strength operator. So how I replace this statement? I replace these statements like this. So actually the both step code is the same. So these are the different techniques of the code optimization. Thank you.